So this question is coming from October number 18, paper 3, variant 1, and this is the fourth question in the paper. We are given the parametric equations of the curve x and y, both are defined in terms of theta, where theta lies in between 0 to pi. The first part of this question is to obtain an expression for dy dx in terms of theta. So whenever you are having a parametric equation and you are supposed to find dy dx, what you do? First differentiate x with respect to theta, then differentiate y with respect to theta, and then divide d theta over dx d theta. Once you're having this, you can simplify it as much as possible and get your answer in the required format. So I'll do dx d theta first. So it will become 2 cos theta plus 2 times cos 2 theta. Differentiation of sin 2 theta is cos 2 theta, and then the differentiation of 2 theta is 2. Similarly, I can find what is my dy d theta. It will become minus 2 sin theta and then minus 2 times sine of 2 theta. Now we have to express dy dx in terms of theta. So I'll just say my dy dx is simply equal to dy d theta over dx d theta. It's the same as writing minus 2. I'll take that as a common factor and I'll have sine theta plus sine 2 theta, which is divided by, again I can take 2 as a common factor and get cos theta plus cos 2 theta, and the 2's get cancelled out, and finally you will have your dy dx expressed in the form of theta. So it will become minus sine theta minus sine 2 theta whole divided by, or you can just have a minus sign outside, even that is fine. It's up to you how you want to express your final answer. So it will be sine theta plus sine 2 theta over cos theta plus cos of 2 theta. And this is your final answer for the first part. The second part of the question is asking us to find, using the first part because of the word hence, the exact coordinates of the point on the curve at which the tangent is parallel to the y-axis. In the previous two questions, you have seen that the tangent was parallel to the x-axis, but this time, let's say if I draw a curve something like this, you can see that the tangent to this particular point will have a gradient of infinity. So basically, this can be expressed as some kind of a constant, that is the change in the y-axis, but the change in the x-axis will be 0. So that is the format which we can equate to our dy dx, and then try to solve for the exact coordinates with respect to this. So let's see how it's going to work over here for us. I'm going to go ahead and mention the second part of this question and say that my dy dx is equal to some constant over 0, and my dy dx over here was minus sine theta plus sine 2 theta, minus sine theta plus sine 2 theta whole divided by, just to not get confused, the minus sign is outside the fraction, and cos theta plus cos 2 theta is equal to k over 0. Now you can do the cross multiplication and get 0 is equal to k times cos theta plus cos 2 theta, and clearly we can see that either k is equal to 0, and of course we don't really care about k is equal to 0, and k can't be equal to 0 in the first place, or else it will be an undefined format. So k equal to 0, this is rejected as k cannot be 0. So rejected, because it will become 0 by 0 format, which is not possible. There is a change in the y-axis, so change in y cannot be 0. Rejected as k cannot be equal to 0. Or you can say that cos theta plus cos 2 theta is equal to 0. Now you can convert this in the format of cos theta so that it looks like a quadratic in terms of cos, and then try to solve for theta. And once you're having your theta, you need to find it in form of, I mean, in between 0 to pi. And once you're having that value of theta, plug it in to get your x and y coordinate. And that is how you will get the exact coordinates of the point where the tangent was parallel to the y-axis. So let us try to do this. So it will become 2 cos square theta minus 1. So 2 cos square theta plus cos theta minus 1 is equal to 0. From this, I'll use my calculator to make the factors. So 2, 1, minus 1. The factors are 2 cos theta minus 1 and cos theta plus 1. 2 cos theta, what was it? Minus 1 and cos theta plus 1. 2 cos theta into cos theta will become 2 cos square theta, so I don't need to multiply anything outside. And this means that, okay, cos theta is equals to half, or cos theta is equals to minus 1. Now we have to find the solution in between 0 to pi, where 0 and pi are not part of the domain. So what I'll do is I'll just draw a rough curve for this one. My cos graph looks like this in between 0 to pi. And at pi, when my x is equal to pi, at that time I'll get a minus 1. And clearly there is no solution over here, so no solutions over here, I'll write. And for this, I can simply say that my theta will be equal to cos inverse of half. And if I use my calculator to solve this, keeping my calc in the radians mode, shift cos and 0.5 comes out to pi by 3. This implies that your theta is equal to pi by 3. Now, because you know the theta equal to pi by 3, you can find out the value of x and y by plugging in the values of theta as pi by 3. So let us try to do that and get our final solution. Substitute theta is equal to pi by 3 in x and y. Therefore, the coordinate will become, x will become 2 sine pi by 3, 2 sine pi by 3 plus sine 2 pi by 3. This comes out to be 3 root 3 over 2. 3 square root of 3 over 2. And y comes out to be what? Let's go ahead and check it. Let me save pi by 3 in the answer. And then 2 cos answer plus cos 2 answer. This is giving me answer of half. So you can have a conclusion that the coordinate at which the tangent is parallel to the y-axis is when x will be equal to 3 root 3 over 2 and y is equal to half. I can also show this to you on the Desmo so that just in case if you want to look into how it visually looks like, you just have a sense of understanding. So as you can see that I have first of all plotted the x of t and y of t. Over here consider t as theta. So these are the parametric equations given to us in the question, where for the theta in between 0 to pi, if I convert them into a Cartesian format, that is if I have to plot x versus y, then it's going to look something like this in between 0 to pi, when the theta is going to be in between 0 to pi. And now on this equation or the curve, we can clearly see at x equal to 3 root 3 over 2 comma 1 by 2, there is a point where the tangent to that curve is parallel to the y-axis as asked in the question. So this is a visual understanding of what you have just accomplished in the question.